Okay, let's go over the first few, see how we did. So we know that the first thing that we need to do is take care of expansion, right? So we have to expand out our terms here. So first, rewrite that radical as raised to the 7/5. And then we would prefer not to do a messy derivative here. So we're going to bring down that radical, and also we can separate these two terms. So bring down that 7/5 and natural log of A minus natural log of B. We got to make sure we distribute that 7/5 through. Okay, so one way to do this is we jump directly into the derivative rule, which is fine. There's another way to do this. I'll show you that in a second. This is my U value, right? My large rule that's involved here is natural log of U. So I have to do U prime over U. So I need to find whatever the derivative of e to the 5x is going to sit in the numerator. And then my denominator is going to be my U value, which is what's inside the parentheses, right? And then what's inside the parentheses here, the derivative of e to the U, which is e to the U times U prime. Okay, minus 7/5. And then U prime over U, power rule. This becomes 15x squared minus 9 divided by U. And then doing a little bit of cleanup here, the e to the 5x cancels out. So I'm left with 7/5 times 5, which is just 7. Okay, another way to do this is if you recognize the fact that natural log of e to the 5x can clean up even more because this is within the natural log expression, I can bring that 5x down and drop that natural log of e, and I'm just left with 7/5 times 5x. And that just takes me directly, right? 7/5 times 5x, the derivative of 5x is just 5, so I can go from here directly to here. But it also works if you just do U prime over U. So. Okay, any questions with one?
You can't simplify the second U prime over U because it's subtraction, right?
This one right here. Yeah, that's right. Exactly. Good. We cannot expand that. If we try to expand it, then that we're using a property that doesn't exist. Yeah. If you can only expand if within a natural log you have multiplication or division. Okay. Yeah, we have to treat this as one thing. We can't go any further in terms of expansion. Okay. Questions with one. Okay. Number two. We have to first rewrite it to help us see what we're working with here. Rewrite it as parentheses raised to the x over 2. We see that this is the need for log differentiation because I have a variable raised to a variable. So the way to deal with the variable raised to variable, we have to involve natural log because we don't have a rule that can handle this form. So we take the natural log of both sides. That allows that exponent to come down. To make it easier to interpret x over 2, I rewrite it as 1/2 x. I'm just kind of getting myself ready for power rule there. So then when that 1/2 x comes down, once that 1/2 x comes down, understand that if you're going through log differentiation with a variable raised to a variable, we cannot avoid product rule. So just know that there's product rule that's going to be expecting that to happen, or expecting to apply that derivative rule. So we're ready for our derivative. Natural log of y becomes 1 over y dy dx. F prime g plus f g prime. 1/2 x becomes 1/2. We keep the g, we keep the f, and then we do g prime, which is u prime over u. So the large rule here is natural log of u. So u prime, the derivative of this expression, goes here. And then the original u value goes beneath. So the derivative of 3e to 2x is 3e to 2x times 2, right? E to the u times u prime, that's e to the 2x times 2. I skipped a step here. I made it 3 times 2 is 6. So I just merged that u prime with the coefficient in front, and the 5x becomes 5. So that's the hardest part, trying to get to that calculus portion. After that, then you're just trying to find a way to get dy dx by itself, multiply both sides by y to get that y over, and then replace y in terms of the original variable.
You do dy dx by itself.
That's right, get dy dx by itself. That's basically your f prime. Okay, moving on to 3. We have an inverse function. And so with inverse functions, we know that the x and y order pairs of your between the function and inverse will be flip-flopped. So if you know 9 is the x value of your g function, then you know 9 must be the y value of your f function. So before I begin anything, I know that g prime of 9, g of 9, and I know that f of something equals 9. So I know that I'm looking for something on the f side of things with the y value being 9. We know this doesn't make sense. This is the one that we want to use, f of 2 equals 9. So if I can set that up, then I know that there's an order pair 9, 2 that lives on the g function. If I can find f prime of 2, then that slope will lead me to the slope on the g side of things. Okay, number 4. Same idea. It's just that we got to do more work to figure out that order pair there. We know negative 11 is the x value of your inverse function, which must mean negative 11 is the y value of your original function. So you set negative 11 equal to the original function, go through a series of guess and check, and then you get x equals negative 3. So my order pair is negative 3, negative 11, which must mean the inverse must have negative 11, negative 3. If I can find f prime of negative 3, then that slope will lead me to the slope I'm really looking for. Okay, so f prime of x, go through power rule, plug in negative 3 to get my slope. Once I get my slope, I can flip it to get my real slope that I'm looking for.
You show on number 3 again.
Yeah. Okay, number 5, we have a log function, log base 10. So you're going to start it off the same way as number 1, natural log. Just the derivative rule is slightly different, or we need to add something with our derivative rule. There's a 1 over natural log of 10 that's going to sit in front of both of your u prime over u. So that's the difference. Are we good with 3 and 4? Okay, so we expand first. We can jump directly into quotient property. Once we apply quotient property, we can bring those exponents down in front. And then once we clean up, then we're ready for our derivative, u prime over u, for both of our log terms with a 1 over natural log of 10 in front of both of my u prime over u's. Okay, if you're good with the first page, go ahead and start on the second page. Go over the answer in about 10 or so minutes. you're stuck on a step or you want to confirm something, feel free to ask.
Why would it be one, why would you be one?
Because within my log base two, it's not, so it's one over L of A times E property. Yeah, you can. So, yeah, product on, so that is A, B, or C, so that's one of the. Yeah, that's basically it. Yeah. That actually. Yeah, that works. And that is nice. So you bring that convex down and start with the. It's good to put the see copies or two separate times there. How does the bottom? And then within each product, within each part of the product flow, I got what each thing you have to touch. The obvious two is one of the objects. Set actually to have it, you have to bring it to.
Otherwise, it's right.
Yeah. Sticks is on the board, see if it's long. Number 7, it's asking to use log differentiation, so start off with natural log of both sides, and you know you can expand all that mess on the right side to make it easier for your derivative steps. This one open last. Right, so again, that x is my u value. It's just like how I did in prime for u here, there's a root of natural log of x, which would be 1 over x. I think, yeah, I know it's easy to get these two confused, right? Because this one, we do look at the exponent. For this one, we don't need an exponent, which is 3 pi. So. Okay, so when that 5 comes down, it's just 5 natural log of x. So.
But they can come down.
Remember, that's the power property, right? Power property allows all the exponents to come down this front. Do that here, about half. Do that here.
Right.
I mean, it's not wrong. I mean, if you do it this way, you'll still get the same answer. This one's. Right.
I don't know how it is. Oh, I guess you did too. I got plus 5 over here. Yeah, it's done. And a negative. Oh, never mind. That just. So.
That's right, yeah.
7 is 5.
This is right. Yeah. You can leave all your answers unsimplified. You don't have to put it all together. That's, yeah, in fact, I'll put it all together. Put it all together, that's correct. It's like half of it.
So why just leave it like this?
Yes, but you got to do one of the like you ideas on the left, and you have to.
I have to add the, this.
Yeah, right.
The process where it's wrong.
I know, like, so I had it there, so 1 over 1.
You like.
You have more of your names right.
So you do it on this one, do it on this one, and you don't read that one.
Yes, UIDX will show up here. It may or may not have UID, one of the UIDX, it depends on the problem. There's no guarantee here, but this one you will. This one you will. This one, yeah, this one you will in this case, but it's not all of them, always guaranteed.
Okay, I haven't been here when we did anything, so.
You just find the derivative and
Okay.
then plug in the order pair to get the slope and different slope. That's all.
It's like exactly what the.
Pretty much, yeah. Those are different, so it's the same. Okay, let me show number 7. So we're able to break that right side up into 3 individual problems. Then once we break them down into individual problems, we can bring all the exponents down in front. Now your answer will be naturally a little messy, but don't try to combine incorrectly, right? Because if you want to combine this, you got to go through a common denominator, which is not worth the trouble. But there's no shortcut around it. So you just have to do your answer in this form. Okay, so don't try to merge things together because then you're adding a step that doesn't have to do it either. Yeah, this is exponential a to the u. So the derivative of a to the u is this one. It looks a lot like e to the u, just with the math log of a.
Sure you get it. Is one of the rules natural log of a times b equals natural log of a plus natural log of b?
That's right, yeah.
Yes.
That's an expansion. They also have quotients on
Zero. But there's no plot on the log of review, if there's not a natural log.
That's right. The natural log of a is there to adjust for the fact that it's not base e. So it's like e to the u, but with a conversion that's happened. So it's natural log of a times e to the u times e. It's not base e, so that's why that's there to force it into base e so that the rest of the derivative can work. Yeah, this one we don't do log differentiation. Just jump directly to the derivative.
Wait.
Do what?
I got them. I'm checking. Would be pleasant to.
Because that negative has to distribute. Yeah.
Well, why would it be one of them? If it's just,
That's right.
why is it one over one?
Let's just clean this.
I don't think it's supposed to.
Because these three terms, yeah, I cleaned that up and I made it memorable. So when I factor dx out, I get 1 minus x minus 1 over 1, and I divided that over. So
I think I just like thought it was why, but.
yeah, I'll put this up. Okay, so number 8, we have to expand. We have to apply implicit, and there's a little bit of product rule that's going on there as well. If you feel like you don't have enough time to write down everything, I have this posted on my website, the key. So tomorrow morning, I will go through worksheet 3 again in more detail. I'm going to work through each of the problems. But I'll be here 7:15 with the help session. Okay. So quiz, no calculator. Make sure you memorize your derivative rule. But basically, it's going to be this with just different numbers. Right, we should go.
For the help session, are you gonna have another review worksheet?
No, it's the same. I'm going to just redo worksheet 3, but I'll go through each of the steps. This is a function, which means that we should be able to represent our derivative without any y's. So we're just understanding that y is only a temporary variable. So we also bring that back. So we represent the derivative just with also, only if there's a log differentiation. That's the only time. This is the best. I'm worried about that.
I just, because it's doing something applying. Like, I know how to do it, but I don't know how to start.
Well,